Cool, thank you. Next.
Hi, I'm Naushad Edilji. I've been a developer for a long time. I graduated way back in the late 80s. I have a degree in physics and math, and I did a lot of programming in C and C++ way back then. I just recently was working with IBM's cloud computing infrastructure software called Flex System Manager, and unfortunately they have layoffs, and so I'm here. I've been doing a lot of open source programming, and I'm really interested in developing apps for Android as well as the Linux platform. I'm a programming junkie, and I love to experiment with new ideas. So that's me.
Hey, my name is Diego Fernandez. I just graduated from NC State in May. I studied math and computer science, and I've been working on a couple side projects while I've been in an internship, but since I've graduated, that internship's going to probably end soon. So most of my experience is using C, C++. I'm trying to dabble with web development now, and I would kind of like to go into web development. Been using Linux for 8 years. Would love to work on Linux. You know, hopefully for people who are supporting open projects, that would be the ideal job scenario. So I don't have necessarily a lot of experience, but I'm wanting to learn. So.
My name is Greg Tarsa. I'm looking for a software engineering management opportunity. I've done a lot of work with operating systems and file systems and storage systems, most recently with NetApp. I helped with their on-disk file system performance work, and also the NetApp flash cache. Then took a hiatus, laid off in 2009, started a college nannies and tutors business with my wife. So I've sort of got a different kind of startup experience as well. And now I miss high tech. I want to get back in. So if you know of anybody, especially in a small company, I've done a lot of things in the 20-odd years that I've been in the business, and I'd love to come get involved with a small company and help make them successful. So Greg Tarsa.
All right, are there anybody here who knows of a position that's open at their company who wants to come? You can stand up or you can come down.
My name's Gary Little, this is George. We both work at a company that we just opened an office in near the 40 and the 54. The company's called Nutanix. It's a software-defined data center, software-defined data stuff. Basically, our IP is in this massively distributed file system that's optimized for virtual machines. Anyway, the open source stuff we use are the code's based on top of CentOS. We use Apache, Zookeeper, and Cassandra for the scalable database. Anyway, we're looking for support people, post-sale support, QA, and system test guys.
Yeah, just come by and talk to us. We have cards we can hang out if anybody's interested. Thank you.
My name's Craig Cook. I work for Java Doc. I don't have a Java space, but get up there and I'll see you. All right, we are going to start our main presentation. I'd like to welcome Michael Tiemann.
All right, so whenever I'm invited to give a talk, I have to make up a title, and it's always an interesting challenge to pick a title that is sufficiently obscure that I can change the presentation underneath and sufficiently attractive that people will actually show up. So I think that the title I handed off is slightly different than what you see here, but the presentation I promise is the same. This idea of open source being the nanotechnology of the cloud, you could see that we are really talking about the next big thing. I mean, if you understand nanotechnology, you understand how big nanotechnology is, right? And unfortunately, I'm glad one person got the joke. And I wish I really did know enough about nanotechnology to give a rip-roaring presentation on all the different things that happen at all those different scales. But I do want to share a couple of my experiences before I head into this. One is that as a VP of Red Hat, I've had the privilege, and before that a founder of Cygnus, I've had the privilege of traveling the world and talking to lots of really, really smart people, and also going and seeing cultural attractions all around the world. And I visited this fantastic museum in Tokyo, actually located in a place called Odaiba, if you have to know. It's called the Mirai-Kan. It's the Museum of Industry and Science and Technology. And I used to think the Exploratorium in San Francisco, California was the best science museum until I saw the Mirai-Kan. And then I thought, okay, well, this is great competition. At the Mirai-Kan, they had an exhibit about nanotechnology that for the first time made me believe I could actually understand how all this stuff works. And what made it such a great presentation was that they didn't just take you from the size of the human hair as being something really big, and then take you all the way down to some nano feature and say, wow, that's really small. Instead, they took you down sort of order of magnitude by order of magnitude and explained how different forces, some of which you're familiar with in the macro world, and some of which become emergent as you go down into these deeper layers, how suddenly chemical and electrostatic and other properties change their behavior at these different scales, and you can begin to understand why it is that people could build these amazing devices just by knowing that the rules change every time you go down a level. So one of the things that I want you all to sort of listen to in this presentation as I wander around it is this idea that there are many different truths at many different levels, and one of the profound things about open source is that every level is open. And that's a big deal, because it may be that the innovation happens near the macro level. It may be that the innovation happens at the micro or the nano level. But the fact that they are all open gives us freedom to innovate across levels instead of just at the magic point of whatever's on the box. If that makes any sense? And then the second thing I want to say, and I'm just going to come right out and apologize. I'm interested in economics. Don't ask me why. Most economists are wrong. But there's something about economics that actually fascinates me, and I do believe that amid all of the other stuff that they get wrong, there are some deep and fundamental truths about that. And as I was trying to think of, okay, Michael, name one. As I was trying to think what I would give you as evidence of that belief, I remember reading a book called The Starfish and the Spider. It's about leaderless organizations, autonomously organized things. Have any of you heard of the Starfish and the Spider? It was a modestly popular business book, nothing like The Tipping Point, nothing like Outliers, but it got a little bit of traction, and it was on a Red Hat reading list a couple of years ago at opensource.com. And one of the first stories that they told was the way that the US Army finally succeeded in quelling this unbelievable insurgent force known as the Apache Indians. Nothing that the American Army could do could break their spirit, could beat their insurgent campaigns, could outsmart or outwit or outflank all the other stuff that they were doing. It was just a big, big problem until somebody opened the can of economics. What they did that ultimately turned that situation to the favor of the US Army, they gave them cows. And cows brought with them this whole management problem that ultimately made these nomadic Indians domesticatable as they domesticated themselves around the cow. So to me, that is actually a story of the power of economics. And now I'm going to go dive all around the world of economics as a way of sort of explaining. I have learned, what I have observed, and what I think represents some of the pathways of innovation for open source. So I'm not going to tell you about any great Red Hat products or anything like that. I'm just going to take you on a little tour of what excites me in the world of open source and economics, and of course, the future of cloud computing. So when I do new hire orientation at Red Hat, I always start off with a slide whose first observation comes from Albert Einstein. We can't solve problems by using the same kind of thinking we used when we created them. And in a way, what Einstein really is talking about is, the fundamental paradox of the paradigm, which is that from within the paradigm, you cannot see outside of it. It is impossible. And in the world of information technology, analysts, these estimates vary, but a number that I think is reasonably defensible is that globally, the world spends $1.5 trillion a year on enterprise IT. And for that money, what do they get? They get 18% every project they start being abandoned before it gets to production. 55% of projects being late to market, broken, or missing key functionality. And when you add all this up, what you see is that there's $500 billion a year going down the drain, which explains why the CIO is not usually the hero of the organization. When you pick up a copy of Forbes or Fortune, they're not constantly talking about how brilliant the CIOs are. They're usually talking about other stuff. And $500 billion a year number sounds like a lot of money until you realize that companies are not spending money on IT just for fun. Consultants tell them that they should get a return on investment between $6 and $8 for every dollar they spend on IT. So if they spend $1, they should be getting back, say, an average of $7, which means that if $1 on the drain, it means that they promised the creation of value of $7 that they're not delivering. Okay? So we not only have this great amount of money being wasted in the form of direct cost, but we have an absolutely enormous amount of money not materializing that companies had actually believed they were going to bring out. So this $3.5 trillion gap is the great unmet expectation of the technology industry, and I think it's really holding things back a lot. Now, when you talk with somebody about spending money on innovation, spending money on technology, IT, et cetera, you can look at the factored probabilities of success and failure. You can basically say, for any new idea that I have, there's a probability it's going to succeed, and there's going to be some kind of benefit of that success. So if you aim big and you succeed, you win big. If you aim low and you succeed, you win a little. But you also have a probability of failure, which is usually 1 minus the probability of success. And you also have that cost of failure. If you aim low, but you have a lot of reputation on the line, you could lose big. If you aim really, really high and you're just a lone wolf, you might not lose that big because, people like that are always aiming really high and failing, so maybe it's par for the course. But if you multiply it all out, and you also have, by the way, the cost of actually doing it, when you run these numbers and you look at industry average statistics, if your probability of failure is about 3 and 4, and the cost of failure could be your job, and half the time, and this is the wildest statistic I've found yet, but half of the time, the expectations of innovation are that you're in worse shape than when you started, right? So, anybody here have any experience with Vista? Right, that's a perfect example where 7 years later than anybody could have possibly expected, it was actually worse than the product it was supposed to replace. It takes a very special kind of company to do that. It takes a company that is exactly 50% of the statistical population. So, there is effectively no rational incentive for innovation, because you're kind of damned if you do, and you're also damned if you don't. Damned if you don't, because $3.5 trillion is being lost due to the status quo. That's the damned if you don't. Damned if you do is, you know, you come up with the next vista. So that's that. Now, against that backdrop, we can look at some other great wisdom from the ages. And Francis Bacon, and this maybe is why I have this unrequited belief in economics. Francis Bacon said, in order to be commanded, nature must first be obeyed. And we're here in EB3 at NCSU, and all they teach here is how to obey nature and the amazing things that can be built when you obey that nature, whether those things fly or levitate or spin around or whatever. Now, when you look at some classical economic advantages, when I was trying to explain to the world what I had in mind when I started Cygnus, the world's first company to provide commercial support for free software, I looked around at some other endeavors that maybe had an analogy. So in the legal profession, legal code is published and anybody is free to actually practice in their own defense. Now, of course, the deck is really stacked against you if you don't know what you're doing, but you can learn to compile law if you want. And what we did at Cygnus was basically offer a specialized capability of knowing GNU software better than anybody else, and we charged, at the time, what seemed like an outrageous amount of money. Now people have to pay so little. But in any event, the legal profession gave us this idea that intellectual property need not be based on secrets, it can be based on competence. And in the world of medicine, the medical community, by and large, has fairly well understood that if nobody else can reproduce the result, it's not medicine, it's quackery. So in the world of medicine, you publish the science, and then it's up to the doctors and the hospitals to be the great practitioners that cause patients to choose them. So we have Francis Bacon talking about understanding nature, and then we have this wonderful quote from Ovid. He set his mind to work on unknown arts, thereby changing the laws of nature. And that's a really exciting idea. The idea that somehow nature is willing to follow new ideas. And in a way, it describes a little bit about what happens as you move from that macro scale into the nanotechnology realm. Of course, I know, I'm not that stupid, I know that quantum mechanics has all these magical effects which at the nanoscale do remarkable things. But if you come at it from a Newtonian perspective, it looks like the laws of nature change as you go down the scale. It also looks like the nature of software changes as you go down the scale. Now, a couple of other analyses of changing the laws of nature. One of the first ideas that convinced me that this open source thing, this free software thing, might have some legs is I thought about how when you take your money to the bank pays you interest on your own deposits, but you don't really get the you yourself don't experience the benefit of other depositors also choosing the bank. I mean, of course, you get stability. You don't want to be the last person. You don't want to be the last creditor of the bank, especially Lehman Brothers, but whose fifth anniversary of demise was, I think, today. But when you think about how open source software works, as I started contributing to Richard Stallman's code base and then recruiting other people to participate in that code base, what I began to realize was not only was I getting paid interest on my own contributions, interest in the form of more consulting contracts and notoriety in Silicon Valley, et cetera, but all these other people I was recruiting, they were also adding value to the code base, which accrued to me just like interest. And so I imagined that there was this funny kind of bank, a software bank, where everybody who deposited their code was effectively getting the sum total of interest of all the deposited code. And that is a change to the law of nature, at least with respect to banks. And then I came across this amazing presentation. It was the Oliver Williamson's 2009 Nobel Prize economics speech. And he talked about the importance of loyalty and trust. And he argued that the most important way to understand the value of a business was based on their relationships around continuity of contractual relationships rather than just prices and outputs. And Williamson, being a relatively modest and humble guy, said, you know, that wasn't something I came up with all on my own. Some other people had published that years before, but I gave you a fancy framework for it, so thank you for the prize. And this idea of loyalty and trust is a super important thing. In fact, Deming in 1982 wrote that companies should strive to build relationships based on loyalty and trust, not based on price. Can you imagine why an open source company doesn't want to base its relationship on price? So isn't it cool that there is this change to the law of nature that you can do business based on long-term contractual relationships? That's kind of cool. And then finally, this excellent quote from Gandhi, which is something I feel every day. Whatever I do will be insignificant, but it is very important that I do it. And one of the other things that I think we see in the world of open source is that when there are mechanisms that can aggregate and amplify all of those insignificant things that people do, changing a line of code here, changing a line of code there, and before you know it, you've got 250 million lines of a Fedora distribution, you know, leaping forward every month. It's absolutely amazing. So you guys are all open source experts, and so you probably know all of these timelines pretty well. But in some sense, these accomplishments up through you know, from 83 to 2002, these really were accomplishments that were very individually driven. They were accomplishable by individuals, and as big as they seemed at the time, they were the result of relatively small efforts. But let's go down our scale a little bit, and rather than look at the individual, rather than look at the projects themselves, let's look at the participants within the projects. There's this great paper published in 2005, which brought a game theory analysis, one of the favorite tools of economists, into the world of open source. And what Baldwin and Clark published was that modularity, when a system has modularity, it allows for increased option value, and if you have also involuntary altruism, or if you have altruism of any kind, whether it's voluntary or involuntary, you get what they called, and what then Tim O'Reilly coined as the architecture of participation. So this graph from their paper basically shows that if you have a single developer, and the developer is faced with a choice of either doing the work and getting the benefit of doing the work and giving away that benefit while they're at it, or not doing the work and then maybe getting the benefit if somebody else does it, what you sort of realize, what this graph anticipates is that if the developer has to do 100% of the work and then give away all of those fruits without necessarily any particular compensation other than the pride of having done it or having solved the problem du jour, the model basically predicts that developer, given that choice, is probably going to say, not that interesting. So that's this point right here, where they do 100% of the work and they get no real benefit. Now, it turns out that they get the 100% of the benefit for doing all of the work. Now, if you can split the job up between 5 people, if you've got a modularity of 5 components, and you can split things up so that maybe half of the work needs to be done for each of these components. So half times 5 means you do 2.5 times the unit of work. You might still actually get 5 people all willing to say, you know what? If I only have to do half the work and we get all the benefit, that's cool. I'll join that project. And so you can muster results for that. And if you have 10 modular components, you can start attracting larger and larger numbers of people who will participate in the project. And in these cases here, what a developer is getting back is 20 for highly modular systems where maybe you don't use all the functionality. if you only get back 25% of the benefit, you might still participate, even if you only get a small fraction back. But if you're the happy bank with Michael Tiemann, where you put in a little and all the other contributions give you back something which is even better than you could imagine in the first place. So you go in thinking you're doing a normal job, you get 200% of the result back. My golly, it's really easy to get a lot of people participating in that way. So have I completely confused everybody, or are you sort of following how this works?
So
Yes.
Is the percentage of work that an individual has to do for a module?
This is actually, I think what this is this is the percentage of value that the person perceives as having done this work against the project. This is what they feel in return. And so obviously when there's a super big return, if you have a chance to work with Richard Stallman, you know that you're going to get back twice as much as you put in, because he can type twice as fast and he can think twice as fast. And so it's a great deal. I used to go to MIT just to have the Richard Stallman turbocharger attached to my little programming engine. But if your promise is you're only going to get maybe even just parity back, whatever you put in, you're getting out pretty much the same thing. Initially, you might just say, screw it, I'm not going to get out of bed. But if it turns out that there's multiple modules where people can join in and participate in a totally quote-unquote efficient world, if you've got 5 modules and each module is returning its 100%, you can do that with 5 people in a command and control. But in the game theoretic sense, if you have the possibility of larger participation, more people will actually go on and say, hey, I want to be a part of that. Yeah, okay? So this was an incredibly validating model for what I had seen empirically through the development of many different open source projects. I had seen the G++ community grow, I'd seen the library community grow, I'd seen the debugging community and compiler backend thing, and then of course Linux completely blew this open and gave a lot of different people a lot of different modular systems on which to play. Now, when you increasing participation plus increasing functionality, plus increasing quality, plus decreasing cycle time, you get this remarkable change to the capabilities of the system. And I think we see this very much in the evolution of the Linux kernel, which I think just hit 3.12 today. Is that right, or is that a joke tweet from Linus? I know he did 3.11 last week, but I think I saw something about 3.12 today. Anyway, this is a graph which is showing how developers contributed to the Apache project back in 2000. So here, developer number 1 is credited with doing 20% of everything. And obviously, in a world of industrial logic, whose rules we know don't apply to software, but if they did, 5 developers could do 100% of Apache. But what we see in the Apache participation world is that the top 5 developers did about 40% of everything. Lines of code added, line deleted, lines of code changed, etc. And in fact, when the software engineering paper from which this is taken compares the Apache community to the proprietary development world, and they find very similar features. They find that developer number 1 does about 20 to 25% of everything, which explains why vaporware is so rampant. You see what your top person does, and you just imagine, well, gosh, in 6 months we're going to solve all these problems. And but basically, between the open source world and the proprietary world, we see very, very similar things where the top 10 to 15 people deliver about 80, 85, maybe 90% of the functionality. But then things are really different between open source and proprietary world, because in this case of Apache, back in 2000, there were 388 different developers working on Apache, and so there's a whole bunch of people doing little tiny bits of work, right? So you can imagine that, and in fact, people would argue for years about whether it was more valuable to have hundreds of amateurs doing almost nothing, or just another 5 or 10 programmers on the junior varsity, basically, acting as the second string, so that when these people, either got married or had nervous breakdowns or both, these could sort of slot forward. So a long time people really kind of argued, would you rather have just a couple handfuls of professional holding, doing that work or these other guys? And they couldn't really articulate what was so great about having so many people do such little stuff. And again, using the nanotechnology analogy, just making something small doesn't make it cool. You got to sort of see what happens when you change those dynamics. Well, what happens in the world of open source is that developer number 388 doesn't even see themselves as an Apache developer. They're working somewhere else, they're doing some other thing, and in the course of their work, Apache does something nuts. And when they chase down, when they try and find the error in their own code and they ultimately exonerate all their own code, and they realize, oh, it must be this damn Apache web server. Having done all the work to try to really characterize what the problem is, they now know what the problem is. So as soon as they see the source code, they know what the problem is, they fix the problem lies, and that is the miracle of open source. The miracle being that what they did not do was to destroy or distort or to damage their own code in a futile effort to work around the bug that's somewhere else. So the big nanotechnology idea here is that by being able to fix the problem where it lies, no matter how small that problem is, right? These are all very small problems being addressed by a large number of people. But by being able to solve those little tiny problems where they lie, the result is an enormous change to the cumulative quality of the code. So when we look at what the industry began measuring in terms of value, in terms of quality, did you guys see the report on Python last week from Coverity? So this software analysis company, which in 2006 published that open source software was between 50 and 200 times lower defect density than the average proprietary software, gave credit to Python for basically blowing out completely the industry average for software defect density. It basically had almost unmeasurable defect density compared to the average. And for those of you who use Python, you're probably really happy that it's a high quality, robust software base that does not constantly bleed bugs the way that some other interpretive platforms do, which I won't name, that are run by Oracle. So when you look at those dismal statistics that I presented up front, 18% of projects being abandoned before they go into production. Do you suppose they were abandoned because the logo was the wrong color? Would that be a reason to abandon a software project? Or do you think it was abandoned because it never worked? Right? Do you think it was abandoned because the font was not in italics? Or do you think it was abandoned because it was so late? Why was it so late? Because it never worked, right? When you start looking at all the reasons why your software might be abandoned, it often traces down to a quality issue. So what open source has really done is it has really changed the paradigm of what is possible to do. And this graph right here shows the SAP Research did a survey of the growth of open source by lines of code in public repositories. And this is basically an exponential growth curve showing that the lines of open source code have been doubling every 12.5 months for the past 10 years. And there's now over 1 billion lines of source publicly available, right? So Fedora with just 220 million or so lines of code, that's just, you know, a small fraction of what's out there. So now here we are, cloud. What about the cloud? So for the last 2 or so years, the industry trade press has been repeating in its own little echo chamber that the macroeconomics of the cloud makes everything so different that the microeconomics of open source is insignificant and therefore irrelevant. And so, you know, the cloud makes open source obsolete. You'll never need source code again. Just use the apps in the cloud. And you know, that could be true. It's a hypothesis. But there's another hypothesis which I would forward, which is that the architecture of participation provides this way of understanding the nanotechnology of what goes into cloud computing. And so instead of simply accepting the magic, which is printed on the box, you have available to you innovation at all those levels to make all those insignificant changes that are very important. And so let's compete these two hypotheses. Okay, so hypothesis one is true. The game is fixed, and we're only going to change the names of the players and the tokens. So the cloud platform is the replacement for the OS. Cloud apps replace traditional apps. Cloud protocols and modules replace software, APIs, and libraries. And if that's true, well, we know what that means. And I don't know about you, but I don't think that's a very exciting feature. Alternatively, maybe there is a new game. I have to say that as a software entrepreneur in Silicon Valley, the thing that drove me up a wall, and probably one of the reasons why I was so ready to move to Chapel Hill when that idea crossed my mind in 2000, was that everywhere I went in Silicon Valley, people would say, "What do you do?" And I tell them my business plan, and they say, "How are you going to be the next Microsoft?" I don't want to be the next Microsoft. That's the one thing I don't want to be. Anyway, who cares? What is exciting is activating this totally different way of approaching software development, software innovation, and stuff like that. So I've been doing open source software since the 80s. I've heard some of you guys mention that time frame. And in the old way of doing things where I grew up, developers created new features and they fixed bugs, which is always a good thing. And then maintainers would do the merges, and I used to be a maintainer, so I know how much fun that is. And of course, with the internet, you do have a very, very low cost of replication. So once you had a release, you could put it up on an FTP server, people could mirror it, and that was all wonderful. What was not wonderful were forks, and the reason is because we didn't have tools that handled forking very well. Now, our company participated in one of the major forks of the early free software movement, the experimental GNU compiler system. It's an example of a thing where some people who were working on the C compiler did not see eye to eye with how the Free Software Foundation was managing that compiler, and they didn't trust us worth a damn. So, so ultimately, we forked these two things. We spent about a year apart, and then we ultimately earned. There's enough concentration of users and enough appreciation for one side that the other side sort of collapsed back in, and we welcomed them back into the fold, and GCC version 3 was born. But forks were very expensive and very highly frowned upon, and that could put an enormous amount of power into a maintainer's hand, and also put the maintainer often in a really hard bind, because who can predict the future? One of the great operating principles of Linus Torvalds is that he is often smart enough to basically say he's not smart enough to make a decision. And so he'll often say, therefore nobody wins. Or therefore everybody wins, and we're going to fork all this stuff. But we didn't have the tools back then to deal with this. And it was a system which ultimately, ironically, became highly centralized. But lately, that has all changed radically because of the model that Git provides, which basically makes forking very, very cheap. And when you have the ability to fork your software, when you can fork your servers with virtualization, and when you can start writing applications which, instead of being these monolithic brutes, take over the whole system, operating system and box, where applications instead become just these momentary assemblies of data and functions, it creates a dramatic world. And to give you an example of of how applications have changed, back in the good old days, people cared about version numbers, right? And so there was,
you know, people would number their operating systems and people would number their applications. And does anybody remember Oracle 7? That was a big deal once. Anybody remember Oracle 8? That was a big deal once. 9, remember that one? That was a big deal once. But, you know, Google search, does that have a version number? Absolutely not. In fact, the code that runs Google search may be different every single time you run that code. That's just, you know, the new way of doing things. So I've got this wonderful new term here, poly-instantiated meritocracy, which basically means everybody doing whatever the hell they want and truly letting the best stuff work. It creates incentives for participation. It creates incentives for innovation. And so it's better for the people who are, you know, trying to start new businesses. It's also better for people who are trying to bring new technologies into their companies. And that was another big challenge that we had when I was a young entrepreneur, was you could do the coolest thing in the world, but if nobody could adopt or adapt that technology, it just wasn't that interesting. You know, what I think that we're seeing in the world of cloud computing, and virtualization really helps this. If somebody's really not sure about something today, just spin up a virtual environment and play around with it. Back in the old days, God, you had to find an unused server, and that used to be a hard thing when people would have, you know, one fixed operating system on a server and people wouldn't give up their old crufty mail servers or whatever. So, final thing that I want to introduce to you, which I think is super cool, is evolutionary game theory. Anybody study evolutionary game theory in here? Anybody hear of game theory? Okay, that's cool. So some people have. Yeah, John Nash really made a lot of great contributions to game theory. He was the subject of a movie called A Beautiful Mind. Evolutionary game theory studies the behavior of populations of agents, think of them as developers, engaging in strategic interactions. That's with their managers. Now here's what's interesting. Behavior change in populations are driven either by natural selection via differences in birth and death rates, or by the application of myopic decision rules by individual agents. So let's look at that second piece first. This idea of a myopic decision rule, this kind of is the logic of the virtue of selfishness. I'm going to do what's right for me, even if it hurts all of you. That's a very myopic thing to do. Right now, there's nobody in the room but me, because I can't see you. So many economic theories are based only on the idea that the only thing that happens is because of the unreasonable man doing it for themselves. And evolutionary game theory says that can happen, but something else can happen as well. You might die young because everybody hates you. Right? And that instance of death will affect the total population that you represent several generations hence. Make sense? You might live a long time because everybody loves you. And so it is both a combination of how the long-term contractual relationships with others work, combined with your own myopic strategies. And I would argue that, you know, that the Git system really makes it easy to sort of play both of those angles very, very nicely. So, applications, let's take this a little bit step further. Let's imagine that applications are composed of and represent these populations that we're studying. And as we try and use evolutionary game theory to look at the success, the long-term success of applications, we now begin to realize that we need to get an understanding of the underlying software development model if we really want to understand the fate and the potential of these populations. Or we can. We could also basically say, let's not peer under the hood. Let's not use the genetic material of the populations to make predictions. Let's just take a snapshot and throw it to a scientist who has no concept of time before, time after, and have them make a guess. Or we can actually look at that DNA, the DNA being the source code, and now we can observe the population, we can observe the interactions, and we can observe the health of the mitochondria. That's cool. So if you've read the book Guns, Germs, and Steel by Jared Diamond, which won the Pulitzer Prize in 1997, fascinating book about what ultimately determined which societies succeeded and thrived and which ones failed across 30,000 years of human history. How many of you have heard of the book Guns, Germs, and Steel? That's awesome. Anybody read it? It's a good read. It's a really good book. He begins the book with a chapter called Up to the Starting Line. What he realized was that the only way to fairly judge why it was that there was so much concentration of wealth and technology in one country and so little in another, the only way to really sort of see where that advantage came from was to dial the clock all the way back to a point in time where humans actually did exist in all the continents that they currently exist in, and none of them had any wealth or technology. So at that point, it was an even race. Okay, so the Australians had their outback and their simple tools. The Europeans had their Alps and their simple tools, and the Chinese had their plains and their simple tools, and the Native Americans, same thing. But in our world of the cloud, though the capabilities, in the book they talk about seeds and they talk about domesticatable animals and they talk about some other functions for human societies, but for us, it's about financial capital. Who has the financial capital and the willingness to invest? Who has the knowledge capital and the willingness to educate? Who has the strong user-innovator population? Who has the internet quality and capacity to connect these people? Is there enabled business value? At the beginning of the presentation, I said that the business value gap, that if we could just fix bad software, we'd be $3.5 trillion per year ahead. That's the idea of having the enabled business value. Now, we might go to some magical land where they never have application problems. They never have operating system problems. They never have any kinds of problems. And every dollar they spend on IT returns to them $6 to $8 of business value. Right? In that world, there is no enabled business value. They've already solved that problem. Fortunately for us, that place doesn't exist. And then finally, we talked about the importance of loyalty and trust. Who is willing to actually manage and measure their trust capital? Because you can have a lot of financial, you can have all of this, but that, and guess where you are? You're September 12th, 2008, when Lehman Brothers collapsed and the whole financial market just froze. Right? That's what happens when that trust goes out of the system. It's very expensive and it's very hard to restore. And so when you look at that, when you look at it on a country by country basis, when you look at it on a company by company basis, you begin to you can begin to see who might the winners and who might the losers be. Jared Diamond did this with human societies. He had different variables in there. But once he laid his framework out, the reason he won the Nobel Prizes, it was so freaking obvious why one set of folks would so far outstrip the other set of folks because of these endogenous advantages. I'm going to skip that, and I'm just going to leave you with this. I confess I recycled this talk from a talk I gave at IIT Bombay, which is a very important technical university in India. I'm wearing this shirt because I bought it on the trip, but India is an amazing place, full of a lot of smart people. It's a country of perplexing contradictions, a lot of knowledge capital, not a whole lot of infrastructure, but a place where I do believe that we will continue to see a lot of interesting potential. But this is a paraphrase of what one of their famous people said, Mahatma Gandhi, of be the change you want to see in the world. Here in the world of software, you can see what can be changed. You can write that as code. You can do it, and then you can be it. So anyway, that's the little conclusion there. So with that, I'd like to know, does anybody have any questions or want to engage in a little discussion before we do whatever else happens at a TriLUG meeting. Yes?
Earlier you mentioned the term involuntary altruism.
Yeah.
Isn't that kind of a contradiction?
That's a good question. Maybe it's not so much of a contradiction, it's just a little bit of tongue-in-cheek. But what involuntary altruism means is that whether you want to share or not, you are compelled to share. And so sharing is the thing which is altruistic, and whether or not you do it willingly or not is the involuntary part. So the EPL is a great example of something which enforces altruism, because you can't forbid people from continuing to share your work. Whereas the Berkeley license, you can do a whole bunch of great stuff and then decide that's as good as it gets. So Apple has done that with OS X, and they've taken the Berkeley operating system, they made a very nice operating system that they've obscured very nicely with DSCL, and they choose. Apple is in total control about whether they want to share something back to BSD. Yes?
Can you talk about the fight between marketing and meritocracy?
Great question. So I may not be that well qualified to do it, because first of all, in Red Hat, all of our marketing guys follow our meritocracy. Just kidding. No, it's kind of, but it's kind of true. It's kind of true. At Red Hat, it's really hard to make up the kind of stuff that other proprietary companies can get away with, just because the code is so transparent. And second, most of my role at Red Hat is more about talking open source policy and strategy with clients, and less about our products per se. So I don't encounter marketing organizations at customers, either in the form of competitors or in the form of their own marketing organizations. But I think I will say that the rules have changed very much for marketing and high tech, in that everybody nowadays recognizes the importance of community. You know, back when Microsoft was ascendant, you know, if you were the #1 product, that's all anybody ever cared about. And today, it's not just about being #1, it's what kind of #1 are you? And so you look at all the different social media choices, for example, and people have become sophisticated, and there are better ways to share in one modality on Facebook, or better ways to share in a different modality on Google, or different ways to share in different modalities on Twitter or Tumblr, et cetera. And all of them are great ways to share with the NSA. I had to throw that in. But I think that, you know, going back to that comment I made about vaporware, and how, you know, the top developer basically does such a large portion of whatever version 2.0 is, that, you know, you just show a little prototype and people think it's all done, and it's not. The world of enterprise software in which I live, that's become less and less prevalent. And really what it's coming down to is marketing not so much making technical claims as basically one marketing organization saying, of course you want to ultimately be able to access the source code, or another marketing organization saying, why would you ever want to access the source code? And that doesn't have a whole lot to do with meritocracy. Yes?
I liked your slides on where you had, you know, the 300, you know, micro contributors and the one person that did, you know, 20% whatnot. I was curious what you thought about some of like the open source projects on like Kickstarter, where I know there's a big Django one recently, you know, money raised that way. Is that kind of going backwards, or is that a scary thing, or?
I think Kickstarter has been a great way of actually increasing the liquidity for projects. You know, I must have been really, really lucky in Silicon Valley to have been able to bootstrap a company by just walking in with no prior business reputation and a relatively small amount of technical reputation, saying, here's the deal, you give me $100,000, I'll make you happy. You know, and believe it or not, customers actually, you know, said, okay, that sounds fair. But what Kickstarter does is it you know, by aggregating, you know, the way we started Cygnus was we started Cygnus $100,000 at a time, and people accused us that, oh, that's free software for the rich. And we didn't have a mechanism to take 1,000 people
who wanted to spend 25 bucks and aggregate that up. And Kickstarter makes that possible. There's a project that's blowing my mind right now called Set Chopin Free. I don't know if you're into open source music or stuff, or Creative Commons Zero stuff. A guy named Aaron Dunn, working in Silicon Valley, has an interest in classical music, and he put a Kickstarter out there 7 days ago and said, we want to raise $75,000 to make free recordings of this part of the Chopin literature.
Repertoire.
And if repertoire, thank you. And if we have a stretch goal of $200,000. 7 days later, he's raised about $60,000 of the $75,000 goal. He's got 39 days left. He's this could be one of those multi-$100,000 things. And he's got like 1,200 backers. And that's amazing. So I think that what Kickstarter really represents is an impedance match of lots of individuals to a big idea. And that's a lot better than just trying to get one or two, or in the case of the venture capital community, you get 3 VCs, and then you're lucky. Yes.
Looking at the trajectory of the cloud, I've seen people now in our community sort of retreat from the cloud a little bit. And say, it sort of strikes me that one of the ideas of networks was that it was decentralizing, but that one of the emergent features of clouds was the huge centralization of these big server spaces at Amazon and Apple and Google. How do you can you sort of map out a hypothetical trajectory of how that system equalizes and what the nodes will look like and what the right size will be for a node, and how we'll sort of get back to a decentralized cloud?
Well, so first of all, I'm a kind of a big believer in everything old is new again. So I think that we will continue to see these fashion trends, and really, whether it is highly distributed or whether it is highly decentralized, is really a function of your perspective at the given level of scale. Okay, so if you stand really, really far back and see everything going through a Google pipe, you say, wow, that's really centralized. Then you wander into their data center and you find out how they map it across all these different computers and how they manage to deal with the fact that every second somewhere a disk is going down in these systems and it all still works. Wow, that's really decentralized. And then you look at how much they have replicated the same software infrastructure across all those systems. Wow, that's really centralized. Again, so or the chip architecture or the disk supplier or whatever. So to some extent, I think it is a question of scale that gives you that answer.
And it's also a paradox.
It is.
Paradox in nanotechnology.
It is paradoxical in that sense. And what I also think is that what we will tend to do is we will tend to focus on either that which we fear the most or that which we love the most. And so if we're all focused on the fear side, then we look at the aspect of the system that we're most afraid of, and that becomes our defining scale. And we sort of miss the other scales. Or also fall in love with how the technology is working, and we could be similarly blinded. And then what's really important is to have enough diversity in the overall set of perspectives that things really are working at the different scales. Let me jump and tell you another story that I learned with one of our great Red Hat customers. I was invited to a science and technology summit in Kyoto in 2006, and I met this CIO who was in the process of starting a new bank that was based on a bank that had failed, and some private investors came in. They said, let's turn these smoking ruins into a new bank. So he had a choice to make. The conventional choice would have been to spend $500 million on software and hardware for this size of bank, and knowing that it would take about 4 years to implement this system, he would have to anticipate what competitive capabilities the bank would need 4 years hence, and then implement to that theoretical target and hope that he hit that target on time, which nobody ever does, and that it was the right target, that was picked 4 years ago, which has also never happened. That was option one. Option two
was to aim for such a simple implementation that it was legally able to operate as a bank, but it had no features that would be in any way competitive other than meeting the minimum standard. But the design of the system was designed for maximum improvability, so that if a customer came to the bank and the customer said, I can't believe you can't, that you don't have feature X of the system, they could go and immediately try implementing feature X and roll it out to that customer.
So a lean startup.
Lean start model, yeah. And in this different scenario, the anticipated cost was $55 million, and the time frame to implement was 1 year. And they took that second option, and in Harvard Business Review, the article Radically Simple IT, published in 2008, explains the great success that they had with this model. Now, the reason I tell you this story is because, do you know any bank that would take a customer request, one day, and the next day say, your feature is ready, why don't you try it? Can you imagine that? It's very hard to imagine. It's very hard to imagine because if any of you have done any work in enterprise software, it takes 18 months to get the damn change through the whole change management system and through release and through all the rest of that jazz. How the heck can these guys do virtually instantaneous deployment? And the answer is simple. They treat innovation as failure. So they have designed their entire system to have no single point of failure, to the entire system to anticipate that anything could fail at any time, and let's be robust with respect to that. And so if the customer says, hey, I need feature X, somebody can feature X and put it into a branch of the running system. And if it works, the customer thinks you're brilliant. And if it doesn't work, you say, oh, the feature's not ready yet. Come back tomorrow. But the system still works because it fails over. Okay? In 2 years, this bank became #1 in Japan for customer satisfaction and loyalty. If they had taken the first option, where do you think they would have been 2 years along that path? They probably would have been 4 years away from the wrong goal. So the point of that is that's a sort of an operational example of how an architecture that recognizes the value of the small scale can have a transformative impact on how the system as a whole functions in the eyes of the customer or in the eyes of the enterprise. Yes?
I'm curious, you've alluded a few times to your career in the 80s. I imagine you weren't born doing open source things, so what sort of transformed you into believing in open source back then?
It was actually reading the GNU Manifesto. I definitely was not an open source guy before reading that. I was definitely a guy who was trying to figure out how do I corner the market on software. And I think what happened was that I was won over to this idea that cooperation was the best macro strategy. Now, if you Google this, you'll see that Bill Joy gets a lot of credit for this. But the true story that I'm telling all of you is that I used this argument at Sun when Bill Joy was present to say this is why Sun should pursue the open source strategy. And unfortunately, the only thing they took away from that presentation was my brilliant quote. and the brilliant quote was, there are more smart people in the world not working for any company than there are smart people working at that company. So draw a circle around Sun Microsystems. No matter how smart all those people are, I guarantee you there are more smart people outside that circle than inside. Same is true for IBM, same is true for Walmart, same is true for the US Army. It's just a simple numbers game. There is no company whose circle is big enough to capture all the smart minds out there in the world. And so to me, the genius of open source, the genius of free software was it was a mechanism to go and actually connect the majority of the outsiders and that was the winning macro strategy. So it was the original 99% strategy.
Yes.
Can you talk a little bit about how you think top level down management of software versus like open source, where it's basically an open democracy, how that affects the total quality and everything of the software?
I think that there is a huge incompatibility between that top-down process and the bottoms-up process. What I've seen at Red Hat is I have seen a sort of an interesting inversion of the management model where, and you've probably seen this on a t-shirt, if the people will lead, the leaders will follow, right? So a lot of very important stuff that management does is to understand what those damn developers are doing and then make sure that the path of that trajectory is reasonably clear. That we have enough financial capital, that we have enough test systems, that we have enough vacation days, that we have enough developers, that other stuff like that. So really, these managers and marketing people, by the way, they're all figuring out how do we make sure that we optimize for the future which is coming from development rather than the other way around. So that's part one of the equation. The other thing that I would say is that and we've told people this for years, but the way that what the Fedora project represents in terms of being the best of what works today in open source gives not only the community a fantastic resource for integration testing a lot of latest and greatest stuff, but it also gives both the managers and the engineers a relatively objective view of what reality is in terms of what open source can do. Now, obviously, Fedora is evolving at a different speed, in a different direction, with a different set of leaders than Red Hat's flagship product line stuff. But what customers are paying Red Hat for is the wisdom to read the tea leaves of this Fedora project, figure out what should be graduating into this, the reliable, stable, consistent release process. And the fact that we have really not had to apologize in 10 plus years is testimony to the value of those managers and developers making the right technology choices. Whereas if we had constantly picked the wrong fork of whatever, if we had constantly picked the wrong file system or the wrong virtualization technology or whatever, then ultimately customers would go find a different solution. Now, in a tops-down world, it's a totally different theory, and Deming railed against this back in the 80s when he was looking at American manufacturing companies. Deming truly believed that there was a tremendous amount of knowledge on the factory floor that American managers were simply ignoring because they just didn't value the people who are actually making the machines or making the products. But in the tops-down world, somehow executives are blessed with an ability to understand the future that the rest of us don't possess. And then they have the ability to command and control these developers into this brave new future path. And when we look at it, all these so-called smart people are terrible at predicting the future. They're terrible when they're in management. They're even worse when they're industry analysts. And,
I think we're all terrible predicting the future.
Yeah,
right.
And so, but actually, the present predicts the future pretty well. And that, in a way, what Fedora is doing is snapshotting a version of reality that is very, it's a very broad spectrum approach. Even enterprise Linux is not as good at predicting the future because we've got this very skewed customer base. It's all a bunch of enterprise people. That's a very non-representative population. It's an important population. They got a lot of money, but it's not the 99%. Yes?
I can throw you a little bit of a curveball.
Go for it.
Thinking literally about the nanotechnology of the cloud. You've been in the open source field for probably more years than anybody in this room. You've seen a lot of trends. Have you given any consideration to whether or not there's a collision course between the cloud that's rapidly maturing and the nascent Internet of Things movement, like the Arduinos and the Raspberry Pis and ever increasingly smaller embedded technologies?
I think that they are symbiotically related. I think that these standalone little elements very much do have their place, and there will be moments in time where they do become connected to the larger cloud, and then other moments where they basically detach and become their own things again. I think that to try to eliminate the agency and the autonomy of every device and turn everything into a cloud thing, that is the matrix. You know, that is the matrix which will need to be rebooted. But if we can, if we can maintain some amount of agency, then that balance between all the little microorganisms and then the cloud, then we're in a place where I think we have a more robust and more realistic environment. Yes?
In the past, you mentioned that there was a centralization aspect to the old open source or free software, and that, in my opinion, helped drive a lot of developers into one little spot so they could work on roughly the same problem.
Right.
When you mentioned the polyinstantiated part, how do you see that working out as getting them somewhat coalesced and moving in some direction as opposed to, you know, poly-direction?
That's a very, very good question. And I think the answer there is that we are, I think, better off with people ultimately being able to make authentic choices than choices which are dictated by the limitations of the tools. Now, that does go against some really major, I'm trying to remember which artist said this, but and it might have been Da Vinci or it might have been somebody else on that level, but they basically said that all art comes from constraints or something like that. So, I mean, there is a little bit of that, but I think it's too easy, and it's definitely too easily corrupted to say, oh, we should all get, you know, some very special set of tools so that developers are constrained, and that will cause them to produce better code, or that will create better behavior. I mean, it is a very, you know, history is full of arguments that basically say, you know, the sooner we can get all the public, you know, into rows and columns, the better it's going to be for everybody. But I think that what happened, if you take that out of the tooling level, if you replace CVS and Subversion with Git, then you get to the point where a developer, you know, developers may scatter into a myriad different directions, and then they sort of realize, man, I'm lonely out here. You know, I'm a fork of one. That's not very exciting. And they can look on the little game theory thing and sort of realize, hey, I'm never going to get a high payoff if I'm living in my own private Idaho. So I would rather developers come to their own conclusion that they're better off working with other developers than to be forced to do so by the limitations of their tools.
Do you see something encouraging that naturally? Not really from a coercive, you know, like a CVS tool.
Yeah. The natural thing is you just look at the horizon and you see, wow, those guys are just knocking it out of the park. You know, and I'm here in the wilderness. What do they know that I don't know? And maybe they're using a better programming language. Maybe they're using a better editor. You know, maybe. and after a while, you run through tools and you realize, no, it's not just the tools. It's also how they've built their community. And so there are open source best practice communities who've done phenomenal jobs at coming out with release after release after release and innovation after innovation after innovation. And you know, when I look at you look at the R project, which has some really ridiculous. I've heard some really ridiculous constraints on their theory of who can check in code. What I've heard is that the R guys decided arbitrarily, we're only going to allow 100 people to check in code. So they created some little artificial thing, which has created its own set of problems. But my God, the software itself is doing amazing stuff. And then you look at Linux, which is, you know, its own interesting socio ecosystem.
Well, that's the reason I was thinking about it, was because you mentioned, like, Linus, he gets to benevolent dictator position, but it also means that the name and the popularity attracts just enormous numbers of people to it.
And although Linus gets all the credit for the Linux kernel, there are full forks of Linux. You know, many of the Linux maintainers have their own trees. That is basically the world in which they live. And from time to time, Linus will say, "Hey, give me some of that," and they'll do a major resync. But Linux is more forked than you would get from just reading the press. Yes.
What is the best editor?
It's Emacs, of course. Yes.
What incentives are going to stop large cloud companies that act like black holes? They just suck in all the GPL software, develop it themselves, but they don't give anything back because they're a cloud company. What incentives are going to change that?
That is a great question, and I think the answer ultimately comes down to customers. I think that customers themselves have innovators. You know, when I go and talk with companies around the world, they don't just want to consume technology. They don't just want to have a transactional relationship with the cloud. They want their own employees to be realized individuals, to be able to participate in innovation. I don't know how many of you guys know the story of Procter & Gamble's innovation strategy. So back in, I think it was around 2006, there was this big story about Procter & Gamble went to their big technology supplier and talked to the CEO, and basically they said, "We're not sure that all these people in our company are properly adding value to the company, and we think that we could do a lot better if we just outsourced all of our technology to you." And so he was really, really happy to get this gigantic contract that everybody talked about. And when that happened, I sent off a little email to Eric von Hippel, who is the guru of user-driven innovation. And I said, you know, in about 5 years, they're going to realize that they've just lost their entire IT innovation capability, period. And it's going to actually ultimately bubble into how their products, you know, compete in the marketplace. Guess what happened this year? That whole relationship was judged a cataclysmic failure because exactly that happened. They lost their innovative capability, and they had prematurely sold out the idea that the future belongs to those who innovate. So what I think is that there is a big challenge. There's the very strong. It's very, very attractive for people to say, okay, I'm gonna leave my innovation keys on the desk, and I'm gonna wander off into the cloud, and I'm just gonna have a great time. But if they don't have that deeper, you know, nanotechnology relationship with open source, what they're going to find years down the road is that they are as stuck as every other customer, and then they're going to need to update Dante's Inferno to talk about this Faustian bargain instead of the one that, you know, Faust did about dinner time. But it's the same problem, and I do think that the onus is on the companies who are involved in technology. The more that we can get customers to engage in technology at every level, the more secure both the customer and the vendor are going to be in that relationship. Yes?
One thing that kind of concerned me in the presentation was that you're talking about the transformative effect of having lots and lots of more open source developers. That's the nanotechnology. And you kind of implied that could possibly change the rules of how businesses operate, such that you start to get better return on your IT.
Oh, that's a good thing. That's a good thing.
The trouble is don't you find a little bit of blowback sometimes whenever you tell people that the rules are potentially changing? Because they might remember back in the 90s when people were talking about the rules having changed.
You're absolutely right. If I had another 2 hours, I'd give a different talk. Or no, I'd give an additional talk about this great book. So if you want to know how to handle that problem, read the book Switch by Chip and Dan Heath. The subtitle is Change When Change is Hard. And I've read the occasional business book from time to time, but what really impressed me with that book is as I was reading the stories that it collected about people bringing change to organizations, I would have this little insight and go, wow, this is just like the time when it totally failed for me, right? Or this is just like the time when it totally succeeded. And I had this new framework to understand a series of successes and failures, blowbacks, and blow forwards, by being able to recognize this fundamental truth that the book really elaborates very well. And the fundamental truth that it elaborates very well is that the human decision system is actually made of two completely independent systems. There's a rational system that believes it's in charge. It believes it is sensible, it's always right, and it's in control, right? And that's the brain that I live in 95% of the time, right? I believe I'm rational, I'm sensible. There's also an emotional decision system. And the rational thing thinks, oh, that we'll deal with that later. It can cry at night. But it turns out that this is not only the thing that controls your fear, it's also the thing that gives you that enormous determination and energy to go do the impossible, right? I had the rational idea of starting Cygnus 2 years before I started the company. But I never started it because I couldn't get over that emotional hurdle of how can a guy with almost no money and absolutely no business experience start a company. And it wasn't until the rational brain heard the reason that made that emotional part happy. And that reason was when people told me for 2 years straight that it's a great idea, but it will never work. I kept thinking, oh my God, it'll never work. It'll never work. It'll never work. But then as I began to realize that every single person that I interacted with in Silicon Valley thought it would never work, guess what I realized? I have no competition. So you're absolutely right that with no other information, people are likely to discuss. They're likely to resist. They're likely to throw all kinds of obstacles, and that's why at the black belt level, you begin to realize, aha, I'm not going to argue with the facts and common sense and reason. I'm going to find out what's going to make you comfortable. And it's not just based on incentive. It's based on answering some deeper question. You just have to find out case by case what causes that person to go, I get it. I get it so much that I want to be that change. Yes?
This might be a little personal question, and you can choose not to answer.
All right.
So Dr. Richard Stallman, he started the ISF Free Software Foundation movement.
Yeah.
And then from your talk, you said you worked closely with Dr. Stallman while you were filing or writing the GCC.
Yeah. GNU C++. Yeah.
So he also mentions in his website the difference between the FSF movement and the open source movement that branched out in 1998.
Yeah.
And you as a VP of Red Hat, the open source affairs, does that have any effect with your personal relationship with Dr. Stallman as of now, or?
I have enormous respect for him, and I also have, I cheer many of the things that he does. He is a great truth teller. One of the challenges of somebody like that is that they are difficult because they don't fit into the comfortable boxes that society creates. And I respect the decision that he has made with respect to being the standard for free software, to be the leader of the movement and to be its embodiment. And I think that there are many people, for example, in India, who are really gung-ho about free software. It's all about self-actualization and stuff like that, and that's totally fine. I became fascinated by the idea of how can I transform business. And if you want to talk about what scares the hell out of businesses, it's personal freedom. It's individual autonomy. That just freaks them out. And I decided that I did not want to try to solve that problem. I was more interested in having a technology revolution than confronting, the inner demons of corporate America. Now,
Why not?
Why not? Yeah, it would be too easy. But
it'll never work.
Exactly. Some of you guys are a little younger, and it can be it's an open opportunity. But I don't do it to thumb my nose at him, and I don't do it to disrespect him. And the fact that he's gone off in one direction, I still think that what he's done is super important, and I hope that the FSF outlives all of us as an organization and as an institution. Is that a good note to end on? Right. Oh, perfect. All right. Thank you.